Okay, Assalamualaikum and good morning class.
Morning, Doctor.
All of you can hear my voice clearly?
Yes, Doctor.
Okay. Okay, I'm doing this session because on last session I asked you to do problem 5. If you are having problem to do problem 5 or example 5, that means you have to repeat again by watching video I passed to you on Monday, on Tuesday or Wednesday. Okay, which is that one is example 2 and 3. Okay, today I just want to highlight something for example 5. I need to share my slide. Excuse me. Okay, I asked you to do this example 5, and if you downloaded the material, you know the solution is given in that handout, but there's some differences for that solution. It's no numbering for metric and everything, and also to calculate Q small and different formula. As what I realized in the Padlet you given to me, some of you follow exactly as example 2 and 3, but most of you follow the given solution for example 5, which is for they are using P and U and also M. Hopefully you understand that same formula but different and different symbol. Okay, let's go for this example 5. Okay, first of all, you have to know here is load of 10 kilonewton. Here is 10 kilonewton. First of all, you have to identify how many nodes for this structure. So as you can see here, one node, 2, 3, and 4. That means we have 4 nodes. So that's numbering for your nodes. It doesn't matter which one you want to do numbering for nodes. And then from this node, you know how many members you have. You have 1, 2, 3, 4, 5. So you have 5 members. So you should able to identify your nodes and how many members. Okay, then you know your X and Y direction, your global direction. So at each node, we have X and Y displacement. So remember at each node you have X, Y displacement. So this is symbol X, Y displacement. Then check the support type. Check the support type for your question and the load given. As I said, we have 10 kilonewton at node 2. And we have pin support, then we have roller. Then you have to label unknown displacement first. Alright, that means you have to check your type of support, where is direction of your load, and from that you can identify unknown displacement. certainly certainly at a pin support there is no displacement on XY, but for roller you're gonna have displacement on horizontal and zero displacement on vertical. That you should able to identify or to differentiate that. Then you start labeling with unknown first. So we know unknown for node 1 and node 2 first. So we go for node 1. So number 1, number 2. Then go to nodes 2, 3, 4. Then you have node 4 and node 3. Between node 4 and node 3, which one you should select first? According to the support type, this is pin, this is roller. This roller can move on horizontal. That means you have to label roller first. So 5, 6. Then last one, 7, 8. Is it clear? Okay. We have 4 nodes and we have X displacement. 4 times 2, we have X displacement. 1, 1, 2, 3, 4, 5, 6, 7, 8. So 8 displacement. That's mean for your K matrix, capital K, your matrix size will be 8 times 8. So if you have 10 displacement, how big your matrix will be? How big?
10 times 10.
10 times 10, and so on. If you have 20, that's 20 times 20. Okay, thank you. Then remember this for one node, for one members with this symbol, small k, the size of that matrix is 4 times 4 because for one member we have x, y displacement, x, y, that's 4 displacement. That means size of that matrix is 4 times 4. Now you have to number your member. To number your member is up to you, no problem. But for displacement, you have to label unknown displacement first. So you give this one is 1, 2, 3, 4, and 5. That's for member numbering. Then near far. For near far, near to far direction, it's from the lowest number to highest number. So between node 1 and node 4, this is near far direction. Between node 1 and node 2, this is near far direction. Between node 1 and node 3, this is near far direction. And between node 4 and 5, node 2 to 3, this is near far. Between 2 and 4, this is near to far direction. Once you identify this thing, use, because in this question not given any length except this 4 meter, but given to you angle. Then use trigonometry to find unknown length. Then back to member 1. You know how to calculate lambda x and lambda y. You know the length, we get 4.619. So use the formula get small k1. So refer back to member 1. Okay, member 1. Okay, this is member 1. Numbering for that one is 1, 2, 7, 8. Numbering near first, then far. That's why near far direction important. So numbering for that one is 1, 2, 7, 8, 1, 2, 7, 8. So inside here, you know how to get. Basically, we just calculate half side because it's symmetry. So once you get that side, simply you can copy to the other side. Alright, is it clear so far for that one?
Yes.
Alright, thank you. Then go for member 2. Do the same. Find lambda x, lambda y. You get the length. So use formula. You get small k2. And refer back for your numbering for member 2. This is member 2. Near far. So 1, 2, 5, 6. So numbering for that one. Member 2, sorry. Where is member 2? Okay, sorry. This is member 2. Member 2. Numbering for that one. 1, 2, 3, 4. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Is it clear? So do the same for member 3. For member 3, you get lambda x, lambda y. Be careful on negative value, okay? If negative, make sure, because you have to check with this formula to find this matrix. Then numbering for the member 3 is 1, 2, where is 1, 2, 5, 6, 1, 2, 5, 6. Okay, next, do for member 4. So member 4, get the lambda x, lambda y, then you can get small k4 for matrix member 4. And numbering for that one is 3, 4, 7, 8, 3, 4, 7, 8. Do the same for k5. Small k5. Please differentiate between stiffness for member and stiffness for overall structure. For member is small k, and for the overall structure is capital K. Okay, do the same numbering method. We get 3, 4, 5, 6, 3, 4, 5, 6 for member 5. Then you have to assemble stiffness for structure, which is capital K. And please bear in mind, this shape is refer your matrix. Don't simply do like this, because there's different meaning. So do like that, like this. This refer as matrix. Okay. So we know we have 4 nodes. That means our matrix size for K is 8 times 8. So you have 1, 2, 3, 4, 5, 6, 7, 8 for column. This one for row. 1, 2, 3, 4, 5, 6, 7, 8. So hopefully you know how to assemble this. For example, we want to know what is value here. So we don't know yet. So the position for that one is column 1, row 1. So please refer back from matrix K1, K2, K3, K4, and K5. Identify in that matrix either we have location 1, 1. For example, for this one, we have 1, 1. So you take this value and then check at another stiffness for member. For example, this one we have 1, 1. So value here is 0. So 0.25 plus 0. Then we have at K5 here 0.25 plus 0.25. Then for K4, we don't have 1, 1. And for K5, we don't have 1, 1. So sum up that value, we get value for that is 0.108. Okay, please bear in mind when you calculate this value, try to use 4 decimal place to be safe. 4 decimal place, okay? So calculate for the all cell, it's enough for you just calculate half side because it's symmetry. If here is 0.25, so here is 0.25 as well. So if here is negative 0.054, here is negative 0.054. That's what I mean symmetry. You calculate half side, simply you can copy it or duplicate to the other side. Then we assemble our K, capital K. Then we know our formula is Q is KD. So this is force, this is stiffness, this is displacement. So when we assemble our matrix, we know this is our K. Okay, that is our K. Between that, we can draw this dotted line. Can you see that dotted line, the pink one, the pink color?
Yes, Doctor.
Yes.
Can see.
Okay, that to differentiate between boundary for unknown and known. All right, refer back your question. From your question, we know which one don't have displacement, which one will get displacement. So no displacement and unknown displacement. So that's the function of this line. Once you calculate that line, you can calculate the vertical line as well. So then due to the support, we know displacement at 6, 7, 8 is 0. Then from your question, force at 1, 2, and 5, no force given, so 0. But at 4, at number 4, force is downward. So downward is negative. So that negative 10. Now we have to assemble this matrix in this shape. So we know 6, 7, 8 is 0. So 6, 7, 8 is 0. So that is known. Okay. So this is the line. So you have how many left? 1, 2, 3, 4, 5. So here 6, 7, 5 line. So here 6, 6, 7, 5. You draw another vertical line. So that's the boundary between unknown and known. Then put in this way, QKD. So here is your Q, this is your K, this is your D. That's what I teach you in example 2 and 3. But some of you are using exactly as the solution given in notes. Hopefully you understand what is P, what is U. Okay. So we know this line. So extend that into D matrix and extend that to Q matrix and also this vertical line. So remember you have this numbering already. 1, 2, 3, 4, 5, 6, 7, 8. It's advisable for you to write this numbering, okay? And also when you answer for the exam, please use the what they call that, the line 1 for your answer sheet. If not, your metric is messy and you tend to do mistake, and I cannot understand your handwriting as well. Then we know the boundary condition given. Displacement at 6, 7x is 0, so 0, 0, 0. That means Q6, Q6, that means Q6, 7, and 8 is unknown. So when unknown, you have to write the name Q6, 7, and 8. Then displacement unknown, D1, D2, D3, D4, D5. And for Q known, at nodes 4, given horizontal, but it's downward, so negative 10. The rest is 0. Then, so we assemble this. We assemble in this shape. Okay. So you know QK. Okay. This QK. And you know where is Q1, where is Q12, Q21, K21, and K22. Okay, refer back here. So this one is K11. Okay. So this one is K12. So this one is K12. And so on. Then, back to here. We expand this matrix. We're going to have two basic equations. We're going to have equation for QK equal to K11 du plus K12 dk. All right. From this equation, we can find our displacement. Then we expand next one, we get QU equal to K21 du plus K22 dk. We solve this, we can get forces. Is it clear? And all of you don't have problem to expand the matrix. Hopefully you learned that previously in, I'm not sure which subject, maybe numerical or ODE, hopefully. Then now we have to expand matrix for QK. So you draw back what is QK, what is K11, what is DU, and what is plus K12 dk. Okay, so this one here is K11 du, and this one is QK, and so on. So you take out that matrix, so you have to expand this. And for your information, our dk is 0, right? So when 0, we can cancel out. So because our decay is 0, so simply we can ignore this value. Simply we can ignore this value because times by 0. So you expand this, you will get 5 equation. So you can solve it by simultaneous equation or Gaussian elimination method. Did you learn Gaussian elimination method before?
Yes, doctor.
Yes.
Which subject?
Numerical method.
Yeah, so you should have no problem to find this simultaneous equation. All right, when you answer your exam, please write how you solve that. I know some of you know the website to solve simultaneous equation. Simply you can write the answer. You have matrix, you write the answer. But for the exam, please write this the solution, okay? Then you can solve, you find D1, D2, D3, D4, D5. So for your answer, still have value AE. Okay. Next, you do for QU. And for that one, decay is none is 0. So you can cancel it out. So just left this matrix. So you expand or Gaussian elimination, you get value for Q6, Q7, Q8. So this one is still capital Q, okay? That for the force. Then you have the force at each direction. So you can check it back whether it's correct or not. As at note 2 given, downward force is 10 kilonewton. So check the summation of Fy, negative 10 plus 5 plus 5, we get 0. So that means your calculation is correct. Okay, clear so far for that? Okay, next you have to find small q. Small q is internal forces in each members. So hopefully you downloaded the material, because my notes just use the formula, but this formula explained in your note how you will get. So in your note you will get these things, Qn and Qf. Qn is internal force near, Qf is for far. And for this small q have the same magnitude but different direction, one positive, one negative. So you can use either Qn or Qf. In my example, I use Qf. So I'm using this formula. Okay. So here you can see numbering near x, near y, for x, for y. That's why your numbering is important. Then you calculate internal force for member 1. You know what is lambda x for that, lambda y. Also you know the length. Then ensemble for Q1. And numbering from Q1 is 1, 2, 7, 8. So you know those value here already. Then you solve this, you get internal force for Q1. Why we didn't take the AE previously? Because here we can cancel it out. So you solve for others, you get what is internal forces for each members. And any of you have a problem to expand the matrix? No problem to expand the matrix? Okay, so this is just recall how to do matrix operation. You have D matrix, A matrix, and C. Size of this matrix for D is 2 times 3. Matrix for A, size is 3 times 2. And the end, you will get result of 2 times 2 matrix. Okay. So this is your row. This is your column. Row, column. To make sure you can do the matrix operation, value here must be the same value, 3, 3. That means you can calculate for that one. And then the result of your matrix is this size, 2 times 2 matrix. So this how to expand your value here. You want to know value here. So here, 2 times 2 plus 1 plus 2 times 2 plus 1 times 3 plus 3 times negative 2. So you get 1. So that just refresh for matrix operation. Okay, everybody clear? Clear? Okay, semua tidur. Okay, later on, you're gonna have a work-based project for stiffness matrix, and for sure, the work-based project, the matrix is not this big. You will get bigger. Then you need to use Excel and assemble this matrix and solve it in Excel. So you can start to learn how to operate your matrix, how to calculate this matrix in Excel. It's up to you. You want to use formula or anything. You can find in Google a lot of references will teach you how to do matrix operation in Excel. So this task for next week. Next week, just a brief. I want you to develop your Excel for this example. Later on, you have to share in Padlet. So by this weekend, you can find it first or just wait until next week, because next week you're going to do and develop Excel for this example. And later on, the same Excel, you can integrate that for your work-based project. Any question?
There is one question from Lutfi in the chat box.
Chat box.
Can we use not A as global direction for NIRFA?
Can we use A? What A?
Not A for global direction.
Not A. Not A. Okay. It is up to you. You know where you choose 0.00. So you can use that point is global. I put global somewhere outside because I don't want to disturb my drawing. That's okay. You can use at A global direction. I put here as my reference XY. You yourself know where you choose your global direction. Okay? Okay, any question?
Okay,
all right. So if no more question, that's all for today. And for next week, I will refresh back what you have to do. I will write in, okay. You're welcome. Okay, so next week, hopefully those are still misunderstanding. Try to do example 5 and refer back example 2 and 3. Try to familiarize with this, because next week you have to develop simple Excel, how to solve that and calculate in Excel. All right. If no more question, that's all for today. Thank you very much. Assalamualaikum and have a good day.
Waalaikumsalam. Thank you, Dr.
All right.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Bye.